Thought I might have a go at videoing myself doing one of these because it might be a little clearer. I'm given a function here and I'm being asked to use calculus to show what the minimum value is. In other words, there's a stationary point, which we write as a stationary point, okay, and it happens to be the minimum, but we need to not only give what the point is, but we have to prove that we know why it's the minimum. So the way we start this is we need to find what the x and y value are. And the way to find the x value, so I'm trying to fill in this box here, is by using the derivative function. So we write out the derivative function. That's going to be 2x plus 2. And then what we do to find out what that x is we make the derivative function 0, or you make the gradient 0. Okay, so it's like null factor. We're going to use the balance method. So we've got minus 2 equals 2x by taking minus 2 off both sides. Then I'm going to divide by 2 on both sides. So I end up with an x value of minus 1. Now to find the y value, so now I'm chasing this bit here, I sub it back into the original equation, not the derivative function. And the reason that I do that is because I'm chasing what the y value is when x is minus 1 in that equation. So I write out that equation. It's just the normal equation where x is minus 1, and so it's x squared plus 2 times x. And now I'm going to solve that. So I've got minus 1 squared is 1, and then I've got 2 times minus 1 makes minus 2. So this one is minus 1, and I've got those two values. Now what I need to do is I need to demonstrate that that is the absolute minimum value, or that is the stationary point. We called it a turning point when we were doing quadratics. And so we draw up this grid. The x values will go in the top, the f dash x values, the derivative function values will go in here, and then the bottom row is for the gradient. Okay, so you could call that m, but we don't. Now, we know that at minus 1, we have a gradient of nothing. And the reason that I know that is because I've already worked it out. So if I choose a different color here, I have worked out here this value, okay? And the purpose of that was because that was when f dash equaled 0, okay? So we've got those two numbers sitting there right in front of us. The whole point of doing the derivative was to find that. It was to find the turning point or the stationary point. So this here will form the stationary point. And what we want to do is find out, is it a minimum or is it a maximum? And the way to do that is to go a number either side of it and to test those values using the derivative formula. So we'll go f dash of x, but this time x will be minus 2 in the first instance, because we're trying to find what this value here is. And so I've got 2 times x plus 2. So that will be minus 4 plus 2 makes minus 2. We'll fill that in. And then I'm going to test f dash when x is 0, as this will be 2 times nothing plus 2. 2 times nothing is nothing, plus 2 is 2, so this will be a positive 2. And now in the final stroke, to decide whether this is a local minimum or a local maximum, I look at this number, I'll change again. I look at this number here, and it's a negative number, which means that I've got a negative gradient. The next number here is 0, so that means that it has no gradient. And then the next number here is positive, so that means that I've got a positive gradient. And I can see here that those form a link like this. So this will be, this stationary point here will be our local minimum. And so this is the correct answer. There can only be one answer for this one, but when we move into some of the cubic ones, there'll be two. So we'll try one of those now. So if I scoot across to this question and we get rid of all of this and we start again, let's try this one. I need to find out the relative maximum of this. Now there will be two turning points in this one because it's cubic. So this would look something like this graph. So we're going to find out what the two turning points are and we'll work out which one is the maximum. So let's do it by, first of all, finding the derivative function. So f dash of x is going to be x squared minus 2x, and that's it. And now I'm going to try and find my x value by making the gradient 0 and factorizing this. We know that x is 0 and it's 2. So we've got two values here. Don't know which one it'll be yet. Okay. And now what we'll do is we'll find out what our two corresponding y values are. So we go back to the original equation and we substitute those values in. So we've got f when x is 0 will be a third of nothing cubed minus nothing squared plus 4. So that one will be 4. And then we've got f when x is 2, and this will be a third times 2 cubed minus 2 squared plus 4, and so this one will be 8 on 3. Okay, so we've got these two values, and now what we need to do is work out which one is the local maximum and minimum. And so this isn't confusing, I'm just going to pair them up. So I've got one turning point, or one stationary point at 0, 4. So I'm getting that from here and here. And I've got a second one that's at 2, 8 thirds. And I'm getting that from that x and that y value there. And now I need to put them into those tables. So let's do that. Okay, now the part that we're going to try to not be confused about is that if this table is x versus the f dash x value, then what we need to do is we need to target a pair first. So I'm testing when x is 0, f dash x is also 0. So when we fill this table out, it's when x is 0, f dash x is 0, and that's fine. What we need to do is work out whether this stationary point is a local maximum or minimum. So I'm going to go one number either side of it, and I'm going to test those. So I've got, using the derivative function, f dash x when it's minus 1. So I'm trying to solve for this here. Okay, so that makes sense. This when that is minus 1. And then we write out the rule. So it's x squared minus 2 times x. And so we've got negative 1 squared is 1, and 1 minus minus 2 makes 3. Okay, so that's nice and clear. We've got 1 squared is 1, and then we've got minus 2 times minus 1 makes positive 2. So we've got 3. So this value here is 3. And then if we test when f dash x is 1, then we've got x squared minus 2 times x. So now we've got 1 minus 2, which is minus 1. This value is minus 1. And we write them in. We've got a positive gradient. We've got a gradient of nothing. It's not going up or down. And then we've got a negative gradient here. All right, so this one is our maximum. And this is going to be the answer. So it is at 0, 2. Okay, so you've got to come back and you've got to pick up the actual set of coordinates. Oh, sorry, it's 0, 4, isn't it? Made a mess of that right at the end. Right, now, just for the purposes of practicing this a second time to make this clear, if we were proving the minimum as well, then what we'll do is we'll draw up the same grid. Okay, at this time we will give it x and f dash x values. And remember that the other point that we were testing was when, and I'll change color again, when x is 2, f dash x is 0. So we can write those ones in as well. So when x was 2, f dash of x was also 0. So it had no gradient. Great. We'll go one number either side. So we'll go down to 1 and we'll go up to 3 and we'll test those ones. So f dash when x is 1 is going to be 1 squared minus 2 times 1. So in other words, 1 minus 2. So this will be minus 1. And then if we test f dash 3, it's supposed to be brackets. This is when x squared minus 2 times x. So this one is 9 minus 6, so it's positive 3. So we can see negative gradient, no gradient, positive gradient. This one's the minimum.